Hello dear all, this is Sachin. Here I am just giving intro to matrix, which one of the easy and important topic for 11th 12th engineering students. What is mean by matrix? Matrix is nothing but just rectangular arrays of elements. That is, elements rearranged in rows and columns. For example, let A be a matrix containing 12 elements arranged in rows and column. Now, we will discuss what is size of matrix. Size of any matrix is given by using its number of rows and number of columns. In general, suppose matrix A contains m rows and n columns, then order of matrix is denoted as m by n, and it indicates given matrix contains m rows and n columns. For your simplicity, suppose suffixes at the base indicates position of element. For example, A11 indicates element in first row and first column. A12 indicates element in first row and second column. A13 indicates element in first row and third column. And so on. A1n indicates element in first row and nth column. In general, AMN indicates element in mth row and nth column. Now we will discuss some definitions of matrices. What is mean by square matrix? A square matrix is an MXN matrix in which number of rows equal to number of columns. If matrix contains m rows and n columns, then matrix is of order m. Particular example of square matrix is as shown in matrix B, that it contains 3 rows and 3 columns, therefore, matrix B is of order 3. Next definition is vector matrix, in which row or column is equal to 1. For example, X contains element in single column and in 3 rows, and matrix Y contain elements in 3 columns and in 1 row. Next definition is definition of scalar matrix, which contains single element. Now, what is meant by zero matrix? Zero matrix is nothing but matrix which contains all zero element. Let us discuss identity matrix. Identity matrix contains all diagonal elements equal to any node T and all non-diagonal elements equal to 0. For example, given matrix B contains 1 at diagonal position and 0 at each non-diagonal position. Matrix transpose, one of the basic and important concept. Matrix transpose of the M by N matrix obtained by interchanging the rows and columns of a matrix that is M by N matrix, converting it to an N by M matrix. In example 1, X is 4 by 1 matrix, that is, it contains 4 rows and 1 column, that is, X is column matrix, and transpose of X is X dash, and it contains 1 row and 4 columns, that is, row matrix. Similarly, example 2 is matrix of order 3 by 4. When we take transpose of A, we get A transpose of order 4 by 3. Students, for fast calculation, do more practice. Up until now, you've been able to add any two things you felt like: numbers, variables, equations, and so forth. Two matrices must have an equal number of rows and columns to be added. The sum of two matrices A and B will be a matrix which has the same number of rows and columns as do A and B. The sum of A and B, denoted A and B, is computed by adding corresponding elements of A and B. Matrix addition is fairly simple, and is done entry-wise. For example, let A and B be any two matrices of 2 by 3 order. Addition of A and B is given by adding corresponding elements, that is 1 added to 5 gives 6, 2 added to 6 gives 8, 3 added to 7 gives 10, 7 added to 3 gives 10, 8 added to 4 gives 12, 9 added to 5 gives 14. We can also subtract one matrix from another, as long as they have the same dimensions. AB is computed by subtracting elements of B from corresponding elements of A, and has the same dimensions as A and B. Multiplying a matrix by a scalar is concept of algebra. Each element in the given matrix is multiplied by the scalar. For example, in given matrix A, when we multiply by scalar x equal to 5, it multiplied to each element of A. In mathematics, matrix multiplication, or the matrix product, is a binary operation that produces a matrix from two matrices. The definition is motivated by linear equations and linear transformations on vectors, which have numerous applications in applied mathematics, physics, and engineering. In more detail, if A is an I times J matrix and B is an J times K matrix, their matrix product of is an I times K matrix, in which the m entries across a row of A are multiplied with the m entries down a column of B and summed to produce an entry of a B. In other words, in order to multiply them, the inner dimensions must match and the result is the outer dimensions. For example, multiplication of matrix A of order 2 by 3 and matrix B dash of order 3 by 2 is given by 1 is multiplied to 5, plus 2 multiplied 6, plus 3 is multiplied to 7, which gives the number 38. Similarly, we get 38, 26, 155, 98. Next is trace of the matrix. Trace of the matrix is the addition of the diagonal of a square matrix. In given example, matrix B contains 7, 4, 9 at diagonal places, and addition of 7 plus 4 plus 9 is 20. Therefore, trace of matrix B is 20. Determinant. The determinant tells us things about the matrix that are useful in systems of linear equations, helps us find the inverse of a matrix, is useful in calculus and more. The determinant of a matrix is a scalar representation of matrix, considered the volume of the matrix, or in the case of a VCV matrix it is the generalized variance. Only square matrices have determinants. Determinants are also useful because they tell us whether or not a matrix can be inverted. Next, not all square matrices can be inverted, must be full rank, non-singular matrix. Example 1 shows that determinant of matrix C which contains single element 4, therefore determinant of C is 4. Example 2 shows that determinant of matrix C of order 2. The determinant of C equals A1 times B2 minus B1 times A2. Particularly 3 into 1 minus 5 into 2 gives minus 7. That is, determinant of C matrix C is minus 7. The determinant of square matrix of order 3 is shown in example 3. A matrix is said to be singular matrix. A matrix is considered singular if the determinant of the matrix is 0. Singular matrix cannot be inverted. Usually caused by linear dependencies between vectors. Non-singular matrix. A matrix is considered non-singular if the determinant of the matrix is non-zero. This matrix can be invertible. The rank of a matrix is defined as rank A equals number of linearly independent rows equals the number of linearly independent columns. A set of vectors is said to be linearly dependent if scalars C1, C2, Cn, not all 0, can be found such that C1a1 plus C2a2 plus n equals 0. Thank you. For more videos please subscribe my channel.